Hello, my name is Matthew Ball. I'm a student of computer science at Florida State University, and this is my presentation on automating software engineering. Introduction. As time is going on, programs are becoming more and more complex. Software engineers need to adapt by producing more and more complex programs. Automation is when programs are made to generate tools without human intervention. Tools are small programs that could produce things to aid the development of other programs. Examples of things that tools can produce are pieces of code, requirements for programs, and test scenarios. Eventually, programs become so complex that automation will be needed to help produce a program in a quick enough amount of time. There are many stages in software engineering, and applying this methodology to different parts of a program would be helpful in producing a program in a reasonable amount of time. These are some advantages of automation. An advantage of automated software engineering is that it can help to make the workload of a programmer more manageable when compared to manual software engineering. Dictier and company discuss how this process can be used to produce tools that map the relationships between parts of a program, where traffic system is being provided as an example where this would be useful. This would allow the programmers to focus on the individual parts and put them together as specified by the map. Breaking the program into pieces with a defined structure would aid the programmers in organizing their programming processes. And program structure is the relationship between components and software. Another advantage of automated software engineering is the tools produced by this process are adaptable. Lewis mentions how tools can be produced by the process and added to a group of tools that can be reused by future programs, with the provided example being the development of vehicle software that works similarly amongst different types of hardware. This would allow programmers to write less code for similar programs if they perform the same tasks, and would allow similar performance metrics between them. Reusing tools would mean programmers would be able to release programs quicker than if the program was made from scratch. This would provide an easier time meeting the client's deadlines. Why companies would want to adapt automated processes is to prepare for a future of more complex programs. As discussed by Dixie and Company, programs are becoming more complex over time, and they need automation and development to effectively manage that complexity. Applying to their example of traffic systems, adopting those processes today will allow companies to be more used to utilizing them in the future when they become more commonplace. Knowing how to use these processes efficiently would be helpful in the production of complex programs that require them. Incentives. As an economic incentive to automating software engineering, less financial resources would need to be spent producing code. Lewis mentions that when software engineers must write new code to perform the same process as previous programs and extensively tested, it takes up more financial resources than reusing tools in their example of producing software for vehicles. Tools could be produced when making a program and reused in future programs. When fewer financial resources are spent, that means that there are higher profit margins. Having higher profit margins is ideal for most companies. As a logistic incentive to automating software engineering, accuracy and efficiency is increased under strict deadlines when compared to manual engineering. It is mentioned by Dinger and Company that automated programs have less inaccuracies under strict deadlines than manual programs, in their case of producing web software. If a client has strict demands about when a program is due, a program needs to be provided in the amount of time they want. An example of when these processes would be useful is when creating large program systems or large websites. These processes help to make the production process more efficient. As a social incentive for automating software engineering, the engineers would be assisted in making wiser decisions in their lives. As mentioned previously, Digner and Company stated that automated programs have less inaccuracies under strict deadlines than manual programs in their field of designing web programs. It can be deduced that one of the reasons behind this is that if the software engineers are given a short amount of time to produce a program for their client, then they would have to work more hours in a day to reach the deadline. Because these software engineers are working late into the night, they get less sleep and therefore have their decision-making skills impaired. With this process doing most of the work, the software engineers would not need to work until late night hours and would therefore be able to make wiser decisions in their lives because they are more well rested. Manual software engineering. It can be used to perform quality control on automatically generated software by reviewing over it. Dinger and Company state that an engineer should look over their web program's code when it creates many dependencies to make sure that they are not hindering the quality of the program, as if their quantity is too great, the program would slow down. Dependencies are when programs call other programs. Running at an efficient speed is optimal for most programs. A programmer could review over the automatically generated code to check if it could be optimized to operate at a speed that would be less intensive on the system it runs on, and could manually program changes to improve the code. Manual programming would be important to use when producing precise programs to do important medical tasks. Pini, Grapetti, and Steenan mentioned that a partially or fully manual process is needed to program laser micromachines due to the precise and quick movements needed from the assembly programming language. A person needs to program precise medical materials because of the needed expertise of the field and the patient in certain cases. A program needs to be programmed with the intention to run at a quick speed using a simple programming language. Particular examples of automation and requirements engineering. Requirements engineering can be automated by helping to generate the requirements of a program. Du and Jin, who tested these requirement producing tools in their computer and plan to test out in industry, discuss how this helps to face difficulties in researching and discovering the requirements of a program, deciding the tasks need to be done to fulfill these requirements, and deciding details of the program's function that are needed for the program's development. Finishing the requirements engineering process faster gives developers more time to focus on later parts of development. Some requirements may be reduced by this process that developers might not have thought of or would have thought of later in the development. Automatically finding requirements early in development saves time compared to when requirements are found later in development, and the program has to be reworked to accommodate to the new requirements. Particular examples of automation and code generation. Code generation can be automated by breaking the code into smaller parts and putting it together. Agrawal and Company discuss a tool that they produced that uses artificial intelligence to generate code by getting individual lines of code from a program and reapplying it using libraries of algorithms and processes, with an example of where this can be used being code for websites. Generating code in this manner can allow parts of one program to be reused in future programs. These new programs are produced more efficiently than the original programs due to there being less original code. Code could still be used to provide new code for the program to reuse. Automation and code testing. Testing can be automated by generating the test cases and having the program run with them. Inu and Company conclude that tests can be generated using less computing power than manual generation in the context of industrial control software. This reduces the amount of time needed to generate tests. This allows for more time for a program to go through the testing process. This leads to the programmers being able to find new test cases in a program that is fixed further. Conclusion. Advantages and issues. Automating the various processes of software engineering will be beneficial to the software engineering processes as programs get more and more complex over time. Programmers get more manageable workloads and the tools produced are adaptable. Some companies would want to use these processes to help prepare for future of more complex programs. The economic incentive is that less financial resources would need to be spent producing code. The logistic incentive is that accuracy and efficiency would be increased when compared to manual programming under strict deadlines. And the social incentive is that the engineers would be assisted in making wiser decisions in their lives. Manual programming is beneficial for the quality control of generated software and the production of precise medical technologies. In examples of stages, requirements engineering can be assisted when requirements are automatically generated. Code generation can be performed by breaking the code into smaller parts and putting them together. and test cases can be generated further testing process. And that is all.